everyone, and welcome to the Nelson Mandela University Science Centre Dome. It was launched last year, and it's one of the exciting, the newest, most exciting projects. We will be doing a little demonstration of some of the dome's capabilities right at the end of this session. So to start off with, I've just heard that we have load shedding at 6 p.m. There are generators, but when the power does go off, please just remain calm, and hopefully everything will come back within 10 to 15 minutes. If the dome's capabilities are still online at that point, we can do the screening then just to save time. Otherwise, we'll just wait until we have mics and sound again to continue the conversation. Just a few notes on safety. If there is, for some reason, an emergency, or the power just doesn't come back on after load shedding for some reason, if you could please go up the nearest staircase and exit via the back. At the end of the session, after the screening, you can also exit via the back. The refreshments will be upstairs. If you do need to leave early or go to the bathroom or something, you can also use the back doors, but please go very quietly. The doors do bang, so you can just be careful with those, and then come back in that way as well. And then if it's an emergency, you can follow the exit signs out of the building and assemble in the parking lot, but I'm sure that won't be necessary. Just a note that food and drink is not allowed in the dome. Obviously, there's an exception for the speakers because they have to talk for 40 minutes. And also note that the equipment around the dome and the dome itself is quite sensitive, so please just don't touch that or anything like that. We're trying to keep it working. I think, and then the bathrooms there's one down here at the bottom outside here. The other bathrooms are, if you're on the upstairs, to the far, my left. So you can use those there. Okay, on that note, welcome to the Mandela and Science Seminar. And I'm going to hand over to our Vice-Chancellor, Prof. Sibongile Mutwa, to please do the welcoming and opening for us.
Thank you very much, Dr. Dupree, should I call you? Thanks so much, Jenny, for recognizing my short stature compared to yours. We've just finished the graduation like a few minutes ago. So if perhaps I pass out, you'll understand why. But it was our last graduation, so it's been a great period for the university, and we're very, very proud of what we've achieved this season. So I want to greet all of you this evening. I will start with the Mandela quote, which says, "None of us will need to be persuaded of the utility of science to national growth and prosperity. But neither will we need to be reminded of its capacity to lend itself to destruction and repression. Whether knowledge is used for good or evil depends on the goals to which we aspire and the decisions we make, as government, as scientists, and as ordinary citizens." So I want to greet our moderator, Professor Nomalanga Mkhize. I want to greet tonight panelists, Dr. Derrick Swartz, who does not need any introduction because he is our former Vice-Chancellor of 10 years. So welcome, Prof. Professor Azwinndini Muronga, our DVC for Research, Innovation and Internationalization. Dr. Zikhona Tywabi-Ngeva, who is also one of the panelists. She's our younger academic colleague. I understand she's on her way. I would also want to welcome her and thank the panelists for making this event possible by leading it with their inputs. The team's interim director, Professor Van Harris, and his team at Teams. I would like to recognize Andre Kiet, Professor Kiet, in his absence. the DVC for Engagement and Transformation, under whom teams fall, and as well as Krishet. Representatives of all faculties that are here. I see the Acting Executive Dean of Science, Zeni Shentu. I know that there are other deans, I'm sure, that have not seen. I want to welcome all the deans and all the academics that are here this afternoon. I hope that all the deans from the science faculties have favored us with their attendance on this occasion. All university staff, students, and community members that are attending here this afternoon, welcome. This afternoon's dialogue is part of an ongoing exploration of what it means for us as a university to be named after Nelson Mandela, with a special focus on Mandela and science. This is our focus this afternoon. I started off my remarks with a quotation about science from one of Mandela's 1996 speeches. Like much else about our namesake, he was able to succinctly get to the heart of an issue. But I suspect that, like many of his other ideas, as you might be aware, his attitude to science was not frozen in time, but it evolved in interesting and complex ways. In 2017, then Deputy President Cyril Ramaphosa, who is now our president, in his address at the occasion of renaming our university, reminded us that in all the cultures of this land, names are imbued with great meaning. He went on to outline a number of areas where we would need to deeply engage, in effect challenging us to explore the meaning and attendant responsibilities that comes with our iconic name. As an institution dedicated to the Knowledge Project, Nelson Mandela University is uniquely positioned to develop a scholarly expression of the Mandela legacy. It was in response to this proposition that the Transdisciplinary Institute for Mandela Studies, known as TIMS, was conceptualized and established. In 2019 colloquium, the colloquium was called Dalipunga, this time that Mandela. A collaboration between the university, the Nelson Mandela Foundation, and the Human Sciences Research Council was key in generating the conceptual basis and thematic areas that would underpin the work of this TIMS project. The framing objective of that colloquium, some of you would have been there, you will recall, and the formulation that continues to guide its work was an exploration of Mandela in italics. The italics are used to distinguish between Mandela the man and Mandela as a social figure, which Van Harris, Anderkiet, and Crane-Sodin, quoting from Gordon, they called it a dense location of scholarly work where history and subjectivity make social life. That colloquium attempted to engage with Mandela in the plural, and through both scholarly presentation and artistic interpretations, such as the exhibition, which some of you might recall, which was called Provoke Ukuchumisa Dag 8 by our Arts, Heritage and Culture Department. Once established, teams began to further the work towards an academic expression of Mandela, the social figure. It hosted 2 workshops in 2021, the first on Mandela posture, identity and scholarship, and the second on politics of cultures and naming. Teams also began to engage at a number of institutional events. This included exploring Mandela in the context of university transformation, decolonization, and a keynote provocation at the 2024 Decentered Critical University Studies workshop about Mandela in a techno-science society. Alongside these engagements, teams also embarked on a series of focus group discussions with stakeholders across the university to get a sense and to make sense of what Mandela means to them, I'm talking about Mandela in italics, in terms of how they are specifically positioned. The findings of this exercise are captured in a report entitled Answering Mandela. Teams also produced a Mandela mapping note entitled Embodying Mandela, which outlined various initiatives already taking place within the university in response to its name change. I would recommend that you familiarize yourself with these works because they get you behind what we're trying to do when we talk about the exploration of Mandela, the social figure, not Mandela, the man. Thus, since its establishment, Teams has worked to explore and map the various shifts in culture, praxis, and knowledge in response to the university's name change, as well as to engage with Mandela, with what Mandela means to the disciplines and knowledge fields across the university and to its various constituents. This is an alignment with one of the themes that emerged from the Talibunga colloquium that I mentioned earlier, Mandela, knowledge production, and the sciences. We were encouraged that we engage with Mandela and science. As the concept note for this seminar points out, it is self-evident that the name Mandela and the person Nelson Mandela have multiple meanings and significations for the university. Furthermore, for the arts, humanities, and social sciences, there are clear pathways for engagement with this figure and its meaning, his history, his social impact, including depictions of him in the arts. Tonight's conversation, however, deliberately asks us and steers us to focus on the significance of Mandela for the natural and other scientists. It asks, does the name signify in particular ways for those in scientific disciplines? Can there be, for instance, a Mandela-inflected approach to engage oceanography, physics, engineering, botany, zoology, medicine, and related fields? We already know that these disciplines are grappling with the calls for Africanization and decolonization. Who can forget the fields must fall movement? Last year, our faculties of science, health and sciences, and engineering, built environment and technology convened panels at the Africanization Decolonization Indaba to share their work in this area. Across these panels, the engagement with indigenous knowledge systems emerged quite strongly. In health sciences, it was the question of the nutritional values of indigenous foods. In IBET, for example, there was a focus on indigenous architectural practices, which are sometimes called vernacular architectures. In science, indigenous knowledge about plants and conservation emerged as a focus area. The importance of engaging with language and the challenges and possibilities of multilingualism in teaching these science disciplines was also a key concern across these panels at the Africanization and Decolonization Indaba, as you recall. It is fitting, therefore, that tonight's Mandela and Science Seminar takes the form of a dialogue, with the opportunity for the audience to engage. What Mandela, the social figure, means to our institution, to its knowledge project, and to its work in service of society needs to be a continual and a communal exercise between all of the university's constituents and among diverse scientific domains. The original founding proposal for the Transdisciplinary Institute for Mandela Studies, TIMS, stresses that, and I quote from the founding document, far from being about Mandela, the scholarly formulation of Mandela in italics is the endless, relentless pursuit to bring an intellectual angle to this figure of justice, to generate new praxis for engaging social injustices, and I close quote. I hope that tonight's conversation will be a generative iteration in this ongoing pursuit. We look forward to our panelists' contribution, as well as what all of us that are joining tonight will bring to this important conversation. I thank you very much this afternoon. Thank you.
Thank you very much, Prof. Mutwa. So I'd like to call up, well, actually first, just again, a reminder about the potential load shedding at 6 p.m. So that hopefully will only be near the end of the conversation. And just a note to the people online that we might struggle to get the live stream up and running again, but if so, we will just share the recording afterwards. So to move on to what we're all here for, the conversation tonight, I'd like to call up the facilitator and the speakers to take the, I don't know if it's a stage. So firstly, the facilitator will be Prof. Nomalanga Mkhize. She's a historian and the current Director of School for Governmental and Social Sciences in the Faculty of Humanities. And then our speakers are Dr. Zikhona Tywabi-Ngeva. She's a lecturer in physical chemistry at this university. Prof. Azwinndini Muronga, who's the current Deputy Vice-Chancellor, Research, Innovation and Internationalization, and he's also a physicist. And Dr. Derrick Swartz, who's advisor, a science, technology and innovation advisor to government and to the ocean sciences at Nelson Mandela University. Thank you.
Is this working? Okay, great. Thank you so much, Jenny. Thank you, and thank you, Vern. Thank you, Vice-Chancellor, to everybody who's here, the Acting Executive Dean, all our colleagues, and of course, our 3 colleagues here who are going to have a conversation which I hope will be very enriching. So I will just start by saying I think we're often warned to be careful of what we wish for. Now, I often wonder about the people that wished for this university to be named Nelson Mandela and not just Nelson Mandela Metropolitan University, Prof. Swartz. I don't know which one of you had that wish, but whichever one of you had that wish, well, you got what you wished for. And so now here's this university with that name. And I think that now that the name is here, suddenly the weight of having to deal with the name and make sure that as it produces graduates, and people talk about Mandela University graduates in the market, and anywhere you go, that people go, Mandela University graduates. So indeed it is, you know, we've wished for it and now we have it. So I think that the work of the Transdisciplinary Institute for Mandela Studies is to keep that thought going so that those who were the originators of the idea are able to pass on the idea, and we're able to really think, what does it mean to carry this name across all the work of the university? So with that, what I want to do is I want to invite each of the colleagues, we can start on that end with Prof. Swartz. I would like them to actually reflect very briefly for about 4 to 5 minutes on what they think the Mandela name invites us to think about the university's contribution to the sciences. And I know 5 minutes isn't enough, but you can do your best. Thanks. On the side.
Good evening. Hi. Thanks very much, Chair and colleagues, and thanks very much for your kind invitation. It's a real privilege for me to be back here. I haven't been here for a long, long while. See our VC is also here, and really humbled by the opportunity to be able to reflect on a brief history that I was part of with a large group of people in the reimagination of the university itself and its name and so on. And I don't want to dig into the sort of like archival and artifactual parts of it, but when I think about the association between the name Mandela And the theme of this evening, science, I think about the sort of values that Madiba stood for throughout his life, and perhaps accentuated in different ways, in different phases of his own personal evolution. You know, the values of compassion, of Ubuntu, of a human society, the idea of social emancipation, of radical equality, a world in which we all can live and work in prosperity and peace and with each other in communion as well. That sort of ideal type vision that he had. And I think all of us registers that when we think about the name of Mandela, and we want to reflect it back on to what the university stands for, its pedagogy, its curriculum, whether it's what we call science or the other branches of knowledge also. But I want to sort of speak at Mandela from a particular tradition that I happen to adhere to, and so more Mandela, the sort of radical insurgent, kind of a subversive element, you know, a revolutionary, a disruptor, particularly in that period of the mid-1950s, in fact, during the Defiance campaign, and of course, during the 1960s until he was incarcerated on Robben Island. And I say that because what we need right now in relation to the debate about science is exactly those sorts of disruptive, transformative, insurgent, guerrilla tactics, so to speak, so that we can invert the dominant models that constitute what we call science and technology and innovation today. And so that's the kind of tradition that I come from. I happen to think, I believe as a socialist, that's how I, you know, so maybe I should declare my things right up on front, so I don't pretend to be objective about these things as well. And that's sort of the sort of vantage point in which I think about science and radically overturning some of the categories on which it is based today, and that shapes much of the discourses in science. Secondly, to say that I think what we're talking about science, I hope VC is more than natural sciences, but I believe social sciences are part of that. All branches of human knowledge requires that sort of a transformation for the world that we have to prepare our graduates for and our citizens to live in as well. So I think about science as constituting all the branches of human knowledge that uses the scientific method or variations thereof to be able to better understand the world in which we live in, and to also to find solutions for the challenges facing our people and our planet. So it's not just natural sciences for me, and when I think about this, I'm, you know, of course thinking about the epic problems facing humanity right now, these huge existential questions of climate change, of global inequality and poverty, about environmental destruction, about the rise of artificial intelligence. It provokes us to approach this in a holistic manner that breaks these Cartesian divides between what we call and we parcel out as natural versus social sciences, to think about the world in holistic terms. Because all you and I look at the world in holistic terms, we just compartmentalize that to break it down, to understand it better, but to generate satisfactory explanations about the world, an explanans as opposed to an explanandum, so to speak, you really need to think about the world in holistic terms, using disciplines, of course, but looking at these transboundary problems and solutions as well. And then thirdly, I think for me, the Mandela mantra and his legend and his promise provokes us to ask fundamental questions about what is wrong about science as we understand it today. And there are three things that comes to mind as when I speak to government ministers and department civil servants, and of course the science community. I think about it in three. First of all, I think we need to interrogate what you know, the notion of science. And I think VC spoke eloquently about that. There is a need to dismantle some of those, the Western paradigms within which science is still trapped and has been trapped for the last 350 years or so. That indigenization, as Moses Kotane once called it, of science is crucial. Africanization, the localization, the contextualization of science so that it reflects and it speaks to the problems that we face in the world as we see and experience it. It can help to resolve the problems, the challenges that the African condition faces, not just reflecting upon the European or the American condition and so on. So that first process of transformation internal to science itself, that it's not only operating within Western paradigms, is crucial if we're going to free up the potential of science to meet its radical sort of potential that I hope that the revolutionary figure of Mandela sort of personified in many ways as well. But you can solve that problem, I would argue. You will still not be able to solve a second problem, which is the impact that science and, of course, the technologies that it produces will have on society unless you look at the relationship between science, technology, and innovation and society. So that dialectic for me is deeply problematic in the way in which power is structured in society. So why is it, for example, that after 250 years of amazing and unprecedented discoveries in science, all branches of sciences, nanotechnology, genetic engineering, artificial intelligence, and so on, we still have more than half of the world's population living in medieval-like poverty, similar to the Victor. It's a paradox. The Mandela legacy for me, the legacy that I want to promote, forces you to confront that central paradox in Western science, which is that despite the fact that we have these spectacular and often unprecedented breakthroughs in science, and we have all these amazing machines in our pockets and so on, yet we live in a world mired in deep structural inequality. So knowledge does not automatically translate into power and inequality. Why? The only way you can address that question is by looking at the relationship between science and how power is organized in society. And I will leave that comment. And of course, that requires you to interrogate the nature of what I would call capitalism, the way in which a capitalist economy works and how it deliberately and systematically cuts off or disarticulates the impact that science can make in transforming society as well. And the third one really is, and last one, I think, I see the chair's already looking at me really dodgy here, is that I think the Mandela legacy also requires us to look at the relationship between science and society, that it cannot be the privy of elites, of the experts alone, even though there's a role for experts, the middle classes, the scientists, the academics. I'm part of that bourgeois society as well. But if we want to truly liberate the power that science has to liberate the human condition, as Amilcar Cabral spoke about so eloquently, we have to revisit the way in which science gets off from its high end and gets into society. And that process, I think, is a supreme challenge for Mandela University, for our university, how to take science out of the classroom, out of the lab, into society, and to empower citizens. I'm a strong supporter of citizen science and community science, civic science, grassroots innovation, and so on, because that's the only way, I think, I propose, Chair and colleagues, that we can break the grip of an elite project, what science has been up until now. And despite major reforms for the last 30 years, and I work with government, we've not been able to break it out of this gilded cage as well. Thanks very much, colleagues.
Thank you. Definitely that will come up, that issue. Doctor, maybe you can share with us, because you are now sort of in the middle level of the system, and you are at Mandela, so you'll be inheriting the legacy. What's your view?
Thank you so much, Chair, and thank you so much to everyone, and to the VC, thank you so much. To the first speaker, Professor Derrick, you've already said a mouthful. You are really a social scientist, because as a natural scientist, I'm like thinking, is that 5 minutes? Because when I needed to sort of like remind myself on what do I really understand by the term Mandela. What does it remind me of? And when I unpack that name, what does it mean for me to be even here in PE? being born and bred in the rural areas like Mkhize village. So for those that do not know Mkhize village, it's actually a village that is outside of Queenstown. It's about 20 kilometers out of Queenstown. And just like anybody else that grew up in the villages, you would know that there is lack of opportunities and there is lack of information that basically translates from the higher above to say this is the opportunity that is available. So when I look at that name, I started asking myself two questions. What am I doing in the classroom that basically shows the legacy of Tatu Mandela's name? This is like my everyday assignment. Am I doing enough in the classroom to translate what the Mandela name's legacy basically carries? Am I doing that every day? If I am not, what can I do to change how I take that legacy and transfer it down to the students that I am currently teaching science to? And for those that do not know, I teach physical chemistry, and I hope my students are not here because physical chemistry, for those that do not know it, it's a type of chemistry module that joins your mathematics. It's got a little bit of physics. You need to know a little bit of calculus. You need to know how to integrate. There's a lot of formulas, and I know a lot of students do not like it. So therefore, that means it's not a very popular module. I'm not saying it's not a nice one, but it's not that popular. And this is because we do know the challenges that a lot of our students that we are currently teaching at Mandela faces, because most of them, they also come from the very same backgrounds that I come from. That is from the rural areas where we come from underprivileged schools, where there were no adequate facilities to teach us and to train us on how to do science effectively. And as Professor Derrick has already mentioned, if it does not start at the grassroots level, it becomes very difficult to try and pick up, especially when you get to the university. Because what it means is that now you need to work twice extra as hard than somebody who actually had that foundation in their high school learning. So that means when I get to the classroom, am I really living up to the Tata Madiba's legacy name? And secondly, I love the fact that whenever we speak about research, we speak about service to society. Because wherever I go and I speak about this, people look at me as if, okay. Because my take is, why do you even do research that is not going to solve your community's challenges? And I'm saying this because, like I said, I come from a rural area, and one of the challenges that we have is that we do not have water, or rather we do not have access to clean water. And there are still some households where they basically go and fetch water using the 25 liters bucket to go and get water. So as a scientist, when I looked at the research projects, I started looking from within my community to say, what are the challenges that we are currently faced with as my community? And if I am saying I'm going to change the world, I cannot change the world if I do not change the world in my vicinity, in my community, in my family, in my classroom. And therefore, it is extremely important that whenever we are talking about the legacy and the name of Tata Madiba's legacy and the name, we unpack it also by saying that we are able to take the research that we do in our laboratories, and it is supposed to solve the immediate challenges that we are currently facing in our communities, in our families. I mean, if in your family you do have somebody that is on diabetic medication, as a scientist or as a health scientist, that is your first point of departure. You should be asking yourself a question. What are some of the things or the skills that I have already learned at Mandela University that can be able to assist me to be able to solve this current problem that we have in my family, where half of my elderly family members are on diabetic medication. And how far do they travel when they want to go and get that medication? So again, I am going to pose everything back to us to say, I know as scientists we really like to do work that is high level, but I'm just going to encourage us to start looking at really at the grassroots level in terms of providing the solutions. And this we are doing because we want to live by the Madiba's name, which is we want to be a service to our respective societies as well as our communities and our families, because we want to change the world.
Thanks so much, Doc. I think I should just say that we definitely need to talk about this question of what is the purpose of science, right? Prof. Muronga, you are one of the top scientists in this country, a physicist. Last I was in your faculty, there was a Russian there telling us about dark matter, and I was sitting there I understood the first slide, then I was lost. But I did understand how we discovered dark matter. That one I must say I'm proud of. So I understood that slide. But other than that, one of the things that's been profound when you've invited the humanities into the science faculty was when you put up that picture of Nelson Mandela with Stephen Hawking. And I don't know if you know that Vern was in the room when that photo was taken. Vern Harris, yeah. You see that photo? That's why I love that photo. Please share your thoughts as one of our top scientists. Thanks.
Okay, no, thank you very much, Nomalanga, and thank you, VC, for welcoming us here. And it's good to see Derrick again here, and Zikhona. Zikhona, we are always around together, yes. So I think it's important to connect, especially when you say what is the purpose of science, basically what is the value of science. And of course, the VC alluded to the 1996 speech by Madiba at the opening of the Academic of Sciences of South Africa, and where he was highlighting that science has got these two sides. Then there is the bad and the good. And actually, Richard Feynman, put it well in his seminal short paper on the value of science, when he say that he came across a Buddhist who told him that there is this golden key, and this key can open both the doors to heaven and hell. And it's up to you, what do you want to use it with? And it's resonate with what Mandela said, when he said, it's up to our aspirations about the science. How do we use it? So that's on the value of science, how we want to use it. I want to connect to what Derrick said at the end, in the end, when he posed the question. Science has been coming up with breakthroughs, but why do we still have these challenges that we have? This is not far-fetched from what Madiba said. It's up to our aspirations. And with that also comes the human aspect, Derrick. I always say the natural laws that are there, they don't dictate poverty. It's us. It's the humans themselves. An example in question, it's when WWW was invented by a scientist, and we said that must be for humanity. It should not be privatized. So you can see the scientists themselves right there, they make a decision that don't go and commercialize this, make it available to the people. So it means, for me, when we discover things at Mandela, do we think about commercialization first? Will Mandela have liked to commercialize things first? Or will he have liked for things to be used by the society for the society? So I'm saying, Derrick, I think we will have to say, look, once science is there, those who have got powers, will they think about really money, or will they think, let's it be used for the benefit of society? That's one, Nomalanga, and I think we will still come to this question, and this question also was addressed by Madiba in '96. It looks like Madiba knew that we will have this sitting here today. When he addressed one of the questions we will deal with now, and that is the question of, do we do the science for just doing the science, or do we do the science for the benefit of the society? And Mandela posed this question, say that we will have to strike a balance between the science that you can use now and what you term Nomalanga as the blue sky science. The dark energy, the dark matter. We don't have the solution yet for that. Yeah, we don't. Someone during graduation say, by the way, VC, one of our council members, Derrick, said, actually I know where dark matter is. If you go there in the dome, yeah, that's where you find dark matter. But there are these questions which also Mandela was pondering about right in 1996. One of the good and the bad of the science, and the other one of how do you strike the balance of the questions, the big questions, that the solutions can come in 100 years' time. And while you're doing that, there is this question that Derrick is posing. How do we make sure that really society benefits immediately out of science? I think that's very important for me. When it comes to the name itself, Mandela, the italic one, and the sciences, I think Derrick and Zikhona already alluded to some of these issues. But for me, it boils down to the practicality. How will I know that this is a science graduate from Mandela? It will boil down to that. How will I distinguish a graduate from Mandela from UCT? As both of them, they're physics students. And they're here, sitting here, and Derrick wants to hire one of them. And will I identify that, okay, that student is a Mandela graduate without actually knowing that he is from Mandela? And that will be the practicality part. So that when we start coining our graduate attributes, do we see a Mandela graduate, a mathematician with a Mandela graduate right there? So I think those will be, for me, the important ingredients for seeing Mandela, the name, through the science. Thank you.
Thanks for the opening remarks. I'm hoping that a Mandela graduate in science will know how Kublai Khan leads to Galileo. Okay, go do your homework. Okay, on the Silk Road. So I want to invite Prof. Swartz to then, let's just explore this further. I think this is the, the mic that was causing the problem. Oh, it's a network, okay. We started with that question of what is the purpose of science. We need to solve our immediate problems, bridging the gap in inequality. It's actually humans, not the laws of physics, that cause the problem. But now, let's get to hard issues. You need to spend money on science. We're a largely working class university. We're making investments in science. Prof. Swartz, you have been in the science system. You are in the science system. You're one of the leaders in the science system. How are we going to strike that balance? What are we going to apply as we think between whether we want to do the blue sky research, which is what happened just after the Big Bang, because I know your students are doing that. I visit the scientists, guys. I know what they do. Versus we need to solve the question of diabetes right now. Professor, how are we going to strike that balance, and how will this help us to produce the Mandela graduate in striking that balance with the money issue?
It's a big problem, Sisi. You, big one. In fact, you were rehearsing a meeting I convened with some of the science leaders just before I was in Cuba last week. So I wanted to make some comments on how inspiring that trip was. But leave that aside for the moment. This meeting was essentially this question: what epistemological and methodological and intellectual rationale do we apply to be able to decide how do we want to, if you use the term balance, I would probably argue some sort of a synthesis, a new synthesis between what we call the basic frontier sciences that discover new knowledge, whether it's in physics and biology and social sciences that people have not known unto this day, versus the application of sciences and the technologies that we already know to solve problems in the real world. That's traditionally the sort of tension in what we call the national systems of innovation, not only in this country but abroad. There's no easy answer to that. I'm afraid, as a policy advisor, we are grappling with that. What I'm arguing for is a kind of a new dialectic between the two, that you have to invest in frontier science, and I'm using science in the way that I sort of postulated it in the beginning. All branches of human knowledge. There is an element about humanity that since the time we walked on this earth, that we are wanderers, and we wonder with an A and an O about the universe. Our ancestors did that when they looked at the celestial skies and they circumnavigated their way across the continent 300,000 years ago and migrated 70,000 years into Eurasia and so on. When we spread our genes that populated, the world as we know it now of 8 billion people, it all came from, it was informed by a quest for knowing, why am I on this planet? Who am I? What is the universe made up of? The stuff that our chair was speculating about, dark matter, dark energy, cosmic radiation, and all these exotic phenomena in the universe. But also, what is life? Are we alone in the universe? Those are huge questions that our ancestors thought about in the caves back then, as we ponder about them now, for which there are no answers yet. So there is a reason why I think we want to know. We are just a curious species. We're called Homo sapiens, wise man. Sorry about the sexist term. But it means an ape with a brain that has been sculpted by evolution on the savannah that can think for her and himself in a way that no other predecessor apes have been able to do so as well. So I think we will continue to have to invest in fundamental sciences. The question is choosing between, if you like, the most exotic, and almost rare inquiries into fundamental sciences versus the ones that we think would probably contribute the best towards, helping humanity find its way out of the difficult questions facing us. I'm putting that too general. I'm going to have to, let me reduce that to a more concrete level. What I mean by that is you can have someone, one of my colleagues here at the university, she's no longer here, but so forgive me if I sound terrible about this. She was doing research in the elephant shrew. And I'm not so sure whether you guys know what an elephant shrew is. It's a tiny little, absolutely, almost like squirrel-like, smaller than a mouse-like. Or there are colleagues that are studying string theory in theoretical physics. There's a school of thought. It's about really explaining quantum mechanics, how the world of the small works. Sorry, Nomalanga, I'm going on and on. Let me just quickly try to explain the point. Now, you can spend hundreds of thousands, millions of rands on chairs and that in quantum mechanics and particularly string theory. There's also quantum loop gravity. There's also another branch also that I won't go into as well. So when you're a physics head of a physics department, like Prof. Azwinndini, why would you spend 5 million rand in string theory versus, for example, on a branch of physics to do with let's say, solid state physics? or on hydrogen, or electrochemistry and so on, you know, that Prof. Zentu is involved in as well. How do you make those choices within the fundamental sciences? They're all fundamental. So that you need to think carefully through, and there can't be arbitrary choices. And as a country, as a system, we'll have to think carefully about that. Similarly, in the applied sciences as well, we'll have to make some choices simply because we don't have the amount of money. I'm very critical of the way the science system is funded in the country, and I think that is completely unacceptable. But it is right now what the problem is, because we followed a neoliberal path of economic development, and we're facing the consequences of that. That's just my view on this issue. But it will require a more transparent framework through which the country will have to make a choice about a new synthesis that we may have to negotiate between the fundamental sciences, which I agree with Azwinndini, that we cannot not invest in those basic questions that move us as human beings, versus the questions that are also about solving real-world problems. And by the way, as he was saying, Tim Lee Burns, who developed the World Wide Web, didn't know the consequences of what he was offering the world as a public good. And sometimes we don't know the things that we're doing in fundamental science that will have a technological consequence down the line. And it could be good and it could be bad, I'm afraid, as well. I'm so sorry I took longer than that. Yeah, thank you.
Thank you so much. Sorry, I was still enjoying while you were discussing all these important things, especially the electrochemistry part. And again, you must understand, I'm very biased. And so I would understand more of that content. So basically for me, I strongly believe that I think all the research scientists that are in this room, they are all going to agree with me. Doing science research is extremely expensive. And it's not for the faint-hearted, because you need a lot of money just to analyze one sample. And I'm just going to bring you guys to the type of research that I do. For one sample, this is just for my samples. I'm not even counting the samples of my students. Today, I was actually given a quotation of about 13,000 rands, and that's about 6 samples, and I only need 3 analyses. And I'm just talking about my samples. I'm not even speaking about the samples of my students that are in my research group. So doing research in science is extremely expensive. And I'm so glad because our dean is here, our VC is here, our DVC of research is here, and all the important people are here. And whenever we speak about how expensive science is, it's not because we are saying we want to be treated in a very special or in a very, sorry. Oh, okay, thank you. Okay, sorry about that. So all I'm saying is whenever we are trying to make that decision, we need to ask ourselves really on the priority list, what is of greatest priority, especially at our university? And again, this is all influenced by the fact that what are the immediate challenges that our society and our communities are facing? And remember, we are in Nelson Mandela Bay. So whenever we are prioritizing, are we going to prioritize research that is going to solve the immediate problems here in Mandela before we extend to the other parts of South Africa and the continent as well as the globe? So I feel that we need to have a framework of some sort, and that framework, it needs to filter down from the government, because the government, even though they do understand some of our needs as researchers, and again, I'm speaking as a very stressed researcher who is doing research with limited funds, so please do understand that I am going to be very touched by this subject. So I do feel that there needs to be like a framework of some sort that is going to look at the priority list of the projects that we need to prioritize as a country first. But also at Mandela, we also need to have our own framework that is going to assist us to be able to see where do we direct most of the funds on which research projects. Are we going to look at the fundamental research, or are we going to look at the blue sky research? And again, the blue sky research is extremely important because we do know that we did not get to the 4th industrial revolution just by jumping all the way to the 4th industrial revolution. We started at the grassroots. That is, we started with the 1st industrial revolution, and then all the discoveries then, they also continued to sort of like propel the researchers to move on to the 2nd stage, which is the 2nd industrial revolution, and now we are at the 4th industrial revolution. So the blue sky is also important because in order to also retain our talent and to keep our talent at Mandela to be intrigued, they need to see that bigger picture. They need to see their contribution as well as what are their skills going to be used into. So again, I think I'm going to agree with Professor Swartz to say we do need a framework of some sort.
No, actually, Derrick knows my stand on this one. You know my stand on this. So, and we agree on the fact that it should be viewed as a symbiosis, no binaries. And I tell you that most of the innovations and inventions that you see today, people didn't go to research for those inventions and innovations. They were doing basic research. The WWW is one of them. The researchers were looking at deep fundamental questions that humanities have been asking. What is matter at the deepest level made of? And as part of that research, the WW was born. The solar panels that we use today, has it not been going to the stars? We will not have them. We were trying to solve deep fundamental questions, and these things became spin-offs. Imagine you have stopped all this, and you didn't fund the blue sky research. No WW, no internet, no 4IR today. I think we need to first put that in that corner to say, even if it's a very small investment in a very small group, the return investment of basic research outweigh your investment that you put. So that's one thing. Applied research, as she was saying, it really needs lots of huge investment. And therefore, Derrick, perhaps what we'll need to look at is to say, but that's a mathematician going to solve a problem. It doesn't need a lab. What is the investment there? It's nothing. Compared to probably we need to build a testing facility. That's the applied part. And which we need to really think deep in saying, how do we prioritize? And perhaps other things can actually do what it is needed, Nomalanga. It's perhaps not the question of money in some of the things. It's to allow the radical Mandela to emerge. And perhaps having a radical Mandela within the sciences doesn't need much investment. It needs space. And as we were discussing, Derrick, that creating of that space of intellectual thinkers might not need us to invest a lot. It might need us to say, Nomalanga, there is this problem that we are struggling with, and we put all these young stars, the radicals, and not to conform to what we are thinking, but we give them space to say, think about really these deep thinking problems that you can come up with the solutions. And I think out of that, something of applications should emerge. If really they're really thinking about these problems. This is the International Year of Quantum Science and Technology. If you go back in history, it's about 100 years, how it was solved. Deep philosophical problems that the youngsters of those days, Niels Bohr and them, they didn't want to go with the flow. they wanted to do something that was not classical. Otherwise, we will still be stuck in Newtonian mechanics, the Newtonian way of thinking. Going tangentially and start giving them space. They were given space, by the way, which today is very difficult to find youngsters who can say, no, I'm not going to follow Prof. Azwinndini. I know you are my supervisor, but can I be my own? We hardly give these youngsters space to start thinking. And if we don't, what we are actually doing, we are blocking future inventions. And I think that's for me, if we want to embrace this Mandela way, will be to give, especially the new generations, to really start thinking freely and invest in that. That's one. And of course, Nomalanga and Derrick and Zikhona, we will have to really think about the whole question of funding a scientific research, not in isolation. Yeah? The Large Hadron Collider, where the same WWW was invested, it's a humanity's endeavor. It's all the countries coming together to do one experiment, yeah? Which one country cannot do. Could we embrace the Mandela's values of us as Mandela University, reaching out to other institutions to say, look, we are here at Mandela, we want to do the following. We know you have got this, and we know we cannot invest in it, but we know you can come on board. That's another way. That's using Mandela way now, and not thinking about this investment in isolation, but looking at what Mandela could have done in this situation. If we can start embracing, putting ourselves in Mandela, the social figure, what could he have done? He could go and ask, what is this gentleman who went to the space? The one who went to space from South Africa, Mark Shuttleworth. He could go. Yeah. So he could go there and say, Mark, look, there is a village here, they don't have school. Can Mandela University start doing those things? But in order to do such, we will have to really have compelling evidence, have that zeal of Mandela to go and convince people that what we are doing, even if it's a hydrogen project, it's worth it. It's worth the investment. And in order to do that, we will have to embrace Mandela, the social figure, the Mandela who can negotiate as an institution. And therefore, the whole question of investment, it's no longer about money now. It's about how do we leverage on the fact that what we want to do is for good as Mandela University, and therefore people should feel like we need to invest. Thank you.
I'm going to ask one really provocative question before we move to the last one, and none of you expected it, and it's triggered by our two leaderships walking in, and I immediately thought about indigenous knowledge systems and connecting to society. Science does not produce SRC presidents. Am I correct? When was the last time an SRC president came from physics, chemistry, guys, you put me in the front, okay? You put Nomalanga. I'm going to ask a difficult question. When was the last time? Because I want our panelists to think about it, okay? Medical school, bit better. They've got some tradition there. But when did we ever have a physicist who is the SRC president? And I'd like to therefore ask a question for us to think about here, because you are triggering this question here, Prof. The radical Mandela that must emerge, the one who has to say to their existing status quo professors, I'm departing from this paradigm in science. Please, colleagues, can you reflect on why there is that structure right now in higher education which seals off or appears to seal off the young scientist in a way that makes it difficult for them to say, no, I'm departing from the paradigm. And I'm just using the SRC thing as just a way to make you see that I think we're going to have an issue in this country where there's a parallel stream. Humanities are going to run the government, ne? And we will decide your budget, okay? And this is the problem. So we would prefer if there was a much better flow between all the domains are giving. And I'm not saying the humanities are doing a good job. There's too much radical Mandela in the humanities. So I think let's start on that side.
Yeah, I want to challenge you again, Nomalanga, on the science, the term science. I think we're trapped in a paradigm, and I know it's so easy. My minister often, when he speaks, he thinks about transdisciplinary science, but he refers to natural science as well. And I think it's just the way our training has been. So I first of all want to say, when I think about science, I think about all branches of human knowledge that uses the scientific method, or something close to that at least, on evidence, hypothesis, theorization, the validation or refutation of evidence and so on, like Karl Popper described so eloquently in his works as well. Secondly, to say that I think you're right about this observation, that it's always been a curious thing for me too, Sisi, on about why, and I think it's to do with the way in which we train natural scientists and also branches of social sciences that have become almost naturalized in the way we talk about them, like econometrics. Economics is no longer a social science, but it's a computational science, it's a mathematical science. It's about precision, it's quantitative, it lacks qualitative methodologies and approaches to validate what it speaks to the world. But if you read the history of natural science, which I studied for many years, there's a rich history of progressive scientists having challenged and contested and in great parts overturned some of the canons of training of natural sciences. In biology, for example, there are many schools of thought and so on. In evolution, the evolution of animals, DNA-based animals that we have on our planet, humans and so on, there are rich debates, since the 1950s. Marxist scholars, which I happen to read a lot about, challenged the way in which what they call bourgeois science in biology shaped the way in which explanations were generated about biological systems, how they evolve and so on as well. And I can go into the details of it, but I just want to say, to make the point here, Chair, that there are rich traditions in geography, in mathematics, in physics, Azwinndini, as you call, and in biology, I know for a fact, of contestations about the way in which we train our scientists, beyond just simply looking at the lab issues and the narrow subject of looking at, let's say, a cell or a bacterium or a virus and so on under the dish, but they look at the whole system in which that is embedded, the organism, and you cannot explain. For example, in genetics, you will not be, I would argue, I come from the school of looking at genetics, you can't explain. The gene doesn't determine the way in which a trajectory of the evolution of a species or a population, because the gene in your nucleus of your cell is part of an organ. That organ is the cell is part of an organism. That organism is in an environment. That environment is not just biological, it's social, cultural, economic, political, and so on. So those forces act ultimately on the evolutionary trajectory, the development path of that species. And I can go into the details just to try to explain the point. You can't explain human beings only on the basis of a gene. You can't abstract the gene from the organism, and you can't abstract the organism from the environment in which that organism is embedded in as well. So we are so connected at multiple levels with nature and society that it requires our scientists, they're not to approach this as a lab rat. I'm sorry to use that term, Sisi. I'm sitting next to a physical scientist. But you have to look at the organism in its environment in total. So we have to teach our biologists, our geographers and so on, all the sort of sets to understand their subject in the context of an embedment in society as well. That is my philosophical approach, my philosophy of science, so to speak, that otherwise the explanation for me is just unsatisfactory as well. So I reject, for example, the works of selfish genes, Richard Dawkins famously talks about the selfish gene, as if the gene operates as an autonomous thing on its own, or the cell for that matter, or human beings. We don't operate in isolation, we're part of communities, societies, cultures, histories, and so on. Therein lies the revolutionary power of knowledge, which I think we must insist that when, the Prof. Zentu trains the scientists in the Faculty of Science, that it must be beyond biology and chemistry and mathematics. Yeah, that's my contribution. Thanks, Chair.
Thank you so much, Nomalanga, and thanks, Prof. For me, I've never seen an SRC president that is a scientist. This is quite true, even in my years of being at school as a student. And I don't even know how to explain this. It's going to sound a little bit funny because when I look at the schedule of a first-year BSc science student, I'm just looking at the timetable now. Some are still in the lab now and finishing off their last practical. And they've been here since 7:45 in the morning. And I'm just trying to think now, where would they really find space to go and sit in those leadership meetings as well as those SRC or student-related meetings where they need to spend a lot of time solving students' problems? Because I'm there and there's 7 other lecturers that are busy hammering down on them to say, I want this by end of business day tomorrow. And again, this also comes from how we have been trained as scientists. We have been trained in isolation. This is the content of our curriculum as well, how we are taught. And I'm the bad guy here because I'm going to share it as it is. But we do not really encourage our own students to take part in the leadership positions or structures within the university. We, as the academics in the science faculties, we do not do that. We do not encourage. And again, what you said, Professor Derrick, is very important, that it starts from within the classroom, because they need to see that they are not only scientists and they are only solving this part of the problem. They need to see themselves as being part of the entire society. And they are not only solving that particular problem in the lab, but they are solving a problem that is going to also require a social scientist who is going to be able to assist them to take that information from the laboratory and to the society. And in our training, we also need to look at what are some of the key skills that we need to transfer to our scientists so that they are a wholesome somebody that actually contributes to the betterment of our societies. So I do know that we're doing a lot of talks because we are in the process of recirculating as the Faculty of Science. And one of the things that actually emerges in our meetings most of the time is what is the content that we are teaching them? Is it business related? Is it only just the scientific innovations? What is it really all about? But do we also speak about leadership? What else do we speak about? Do we also encourage them to take part in the leadership structures within the university? Do we encourage them to also get to know exactly what is happening in and around their communities? Because again, if we are only teaching sciences and hard sciences only, we are going to have graduates that are not able to coexist with their respective communities. And I got to learn this. It was a shocker. I want to say this. It was a shocker for me because I always knew that I just needed to be a scientist and then that's all. But I needed now to learn other soft skills, how to speak, how to communicate my science to the different audiences. I needed now to also understand exactly what are some of the examples that I use in my classroom so that I am able to draw, or rather to inspire the next upcoming scientist that is sitting in that particular classroom. Do I use the very same examples that were used when I was being taught? Do I use the parachutes as an example of trying to understand what the properties of the gases are? Or am I going to use a, hey, you have seen in your Rondaville, in that village, there is going to be that particular what, to actually try and bring even someone from Mkhize to understand what I am trying to explain as a concept of science, but using their relived, or rather their lived experiences that they are familiar with from their own backgrounds. So again, there is still a lot of work that we need to do, but it all starts with us, and it starts in the classroom. It's not going to emerge only when they get to be graduates, but it starts with the content and the curriculum that we are currently teaching them. And I love when you touched on the indigenous knowledge. The indigenous knowledge is quite broad because it also speaks about the language. And the language, it also speaks to how do you explain your science to your 81-year-old grandmother that lives in Mkhize village. Will she be able to understand exactly what you are trying to do in the laboratory? Or you want your audience to be only Professor Azwinndini, who is going to understand exactly the innovation that you have discovered in the lab? So again, it's a whole lot of things that we need to try and,